Hi everybody. Today I'm going to talk about numeral system, how computer works, how computer understand the electrical components with each other, and you can understand the output of the computers, how they gonna transfer numbers with binary system to the 10 unit system. Okay, let me give you content about this chapter. At the beginning, we will be talking about what's the objective of this chapter. Then we're gonna introduce the numeral system and decimal numeral system, binary numeral system, and we will always also talk about how we're gonna convert binary to the decimal and converting decimal to the binary system. That at the end we will talk about converting hexadecimal to decimal and decimal to hexadecimal system. The objective of this chapter is you need to familiarize with the method the expressing numbers and convert one method to another method. Okay, that's your objective of this chapter. Let me introduce you about the numeral system. The writing method for expressing numbers is called the numeral system. In the first method, we are writing numbers with combination of 10 systems. It is 1, 2, 3, 4, 5, 6, 7, 8, 9. But don't forget the 0. It's called digits, and the numbers that are expressed with 10 digits that are called decimal number or base 10 numbers. The other methods are binary, hexadecimal, and etc. The binary numeral system or base 2 number system represent numeric values using two systems which are 0 and 1. More specifically, the usual base 2 system is a positional notation with a radix of 2 because of its straightforward implementation in digital electronic circuitry using logic gates. The binary system is used internally by almost all modern computers. Okay, decimal number system. In the first method, we will discuss and write numbers with combination of 10 symbols, which are starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, called digits. Numbers that are expressed with 10 digits are called base 10 numbers or decimal number system. For example, you see on the screen 2 is only one digit, 45 is 4 and 5 is 2 digits, 643 is 3 digits, and 7785 is 4 digit, 8785. Each one is a 1 digit. Now, you see on the screen in decimal number system, the value of digit is multiplied according to its placement in numerical sequence, which we call base number 0, 1, 2, 3, blah, blah, something else. From right to left, we're going to talk about from right, first digit, second digit, third digit, fourth digit, fifth digit. That's the point we're going to talk about then. And you go for first digit is 10. You see? It's pen. And this one is first digit, as you see. Okay. This is the first digit. We can talk about that. And this one is second digit. This one is third digit. The first digit is base number 10 system. Multiply 1 times 10 power 0. Because it's a 10 base, it's a zeros digit, first digit, second digit, third, then it goes on. And second digit is base number 1. 10, this is multiplied, this is the first digit, isn't it? And what we're going to do is 10 over 0 multiplied by 1. It means 1. If it's 10 over 1, it means 10. You see? 10 over 1. 10 over 3 2 is its third digit is 100. 10 power 3 is it, which means 3 0 it's 1000, etc. It goes on and on. Let's say that one in base. What I said, it's in a, the first digit is it 10 over 1. Second digit is 10 over 1 is 10, and it's go on and on. Okay. Let's give an example. Okay. If we have a two-digit numbers, and if it's 20, we're gonna talk about that. If its first digit is 10 over 0, isn't it? Multiply by 1, is it 0? Second digit 10 over 1, is it 10 multiplied by 2? Because this first digit is 10 over 0, and second digit is 10 over 1. And the second example, we always come from the right side. Okay, in that part we're gonna talk about 6 4 5 6. This is first digit. Okay, we can multiply 10 over 0 is 1. Okay, second digit 5 times 10 over 1, which means 10. Third digit 4 multiplied by 10 over 2, which means 100. So we can get this number on that. The other examples, how many digits we have? 1 2 3 4 5 digits. Okay, 5 digits. First digit is number 8. Let me get an arrow here. That this is the first digit. Is it okay? Oops, sorry for that. Let me say that's what pen. This is first digit. First digit means 10 over 0 times 8, isn't it? 10 over 0 is 1. Multiply by 8. So it is 8. Second digit, it's that. Second digit, 10 over 0. Sorry, 10 over 1 means 10. Multiply by 6. 6 come from there. So it means 6 multiplied by 10, 16. Third digit, which is 10 over 2, which means 10 over 2 means 2 more 0 after 10 is 100. Multiply by 5, which is 3 digits, it means 500. Then the other one, third, 10 over 3 and 10 over 5 means 10,000. So multiply by 8, it's all come for 4,000 and 80,000. So if you add them each other, then you get the result 84,568. That was 10-digit numbers. Okay, now we're gonna talk about the instead of decimal number, we're talking about the binary number system, numeral system. Numbers represent with two symbols, which are 0 and 1. They are called binary or base 2 numbers. All computers, electronic calculators, all kind of tablets and smartphones and other phones as well use binary numeral systems because they are all electronics. Let's give some example. Okay, one digit is it's 1. Second digit is 1 0, 1 and 0. There's a 3 digits, but the only two symbol can be used 0 and 1, 1 0 0, and 4 digit 1 1 0 1. That's the way it works about that. When we talk about the binary numeral system, you see that's the way we can. This is first digit, second digit, third digit, fourth digit. Of course, we always use two-base system binary. That's why first digit is 2 over 0, 2 over 1, 2 over 3, or 2 over 3, 2 over 4, 2 power 5, like that. Okay, each one you multiply by the number you got, either 1 or 0. If you multiply anything in 1, 0, it means 1. Let's give some example about that. Okay, first digit base number is, if you have a 1, we can talk that it's 2 over 0 means 1. Okay, that's the way. If you have a second digit is 2 over 1 is 2, isn't it? 2. That's the second one. Second digit base number 2 over 1 is 2. That's 1. If you want to talk about the, that's what I meant. And to 3 digits we can talk. Third digit is, base number is 2. Okay, 2 over 2. That's it. It's 4. And the fourth digit is, base number is 3. You see, that's 1. 2 power 3 means 8. That's the way of binary numeral system. Let's we talk about it, how we're going to convert binary to decimal system. To convert the binary decimal system, we're going to use that way. Remember, we have number 10. It's binary, and we're going to convert to digits. Binary number, you say, always starting from the right. Understood? When we start on right, this is first digit, this is second digit. First digit 0. This 0 comes from this one. This one comes from this one. Okay. Now, for starting in binary system, 0 multiply what? 2 over 0. 2 over 0 means 1. 1 times 0, it means 0. If you have second digit, it's 2 over 1 means 2. Multiply by 1, it becomes 10. 2 plus 0, it's 2. Then we can say that 10, 1, 0 is in binary system, is represented in decimal system called 2. Okay. Let's talk about another example. 101. Remember that we have only 2 digits. We have only 2 digits, 0 or 1. This is first digit, second digit, third digit. Always multiply that number by 2 over 0, which is 1 times 1, it's 1. Remember that 2 over 1 multiply 0, 2 over 1 is 2, 2 times 0 is 0. Then 2 over 3 or power 3, it's simply 4. 4 times 1 means 4. Then add each other, 4, 0, 1, it makes 5. Then we can say that 101 in binary system is equal to 5 number. Let's give another example. This is the same way. This, we have to talk about that. First, write down the digits what you have. It's 1, 1, 1, sorry, 0, 0, 1. Which are the digits comes from the question, binary. Then starting from here, 2 over 0, 2 over 1, 2 over 2, 2 over 3, 2 over 4. And you'll to first multiply, then add each other, it's become 25. And same process goes on to our last questions. We have 1, 1, 1, 1. Sorry, that. We have 1, 1, 1, 1. I'm talking about this one. This is then 0, 1, 1. Of course, now we're going to talk about the simple saying like thing like 2 over 0, it's mass. 2 over 1, it's 2. 2 over 3, 2, sorry, 4. 2 over 3, 8. 2 over 4, 16. 2 over 5, let's say 32. If you first multiply, then add each other, make it 59. Let's do the different way. How we gonna convert decimal to the binary system? This is a little bit tricky things. You have to pay very good attention on this presentation to understand how it's going on. If you want to convert decimal to the binary, we have to divide each decimal number by 2. If there is a remainder, the rightmost column will be 1. If there is no remainder, the rightmost column will be 0. And if you divide everything to either 1 or 0, isn't it? Then repeat the process, moving one column to the left each time until you have divided down to 0. Let's say 15. First of all, divide 15 to, it means 7, isn't it? But we have number, remainder is 1. So we put this 1 here. Okay. That's the one. If you come another one, there is 7 left. We divide 7 3, still we have remainder. Now we are adding that left of that. This one comes from here, and this is the extra new one. If we 2 3, we divide 2, again we have 1 remainder. So we have 3 1, and there is a 1 remainder. Do we have anything to do that? No, this 1 is left. So that's why we're gonna put everything 1 1 1 1. So if you do this decimal number to the binary, that's the way you got 1 1. Well, you can double check if it's true or not. Let's say that this is 2 over 0, isn't it? 2 over 0 means 0. If it's 1, 1 times 1 is 1. This is 2 over 1, it means 2. 2 over 3, 2 over 4. If you multiply everything, you will find the number 15. Okay, let's do another example. 74. If you first divide the 74 to 27 is remainder. Is there anything remainder? No, it's 0, because 2 times 37, 74. So remainder 0. But you make sure that if you divide 37 to 2, it's got to be a 1 remainder, because it's 18. Then 1 comes after the 0 from left side. If you divide 18 to 2, of course the remainder will be 0. There you go. And the 9. And the 9 divided 2, it comes 4, but remainder is, of course, 1. And then 4 divided to 2, remainder is 0. And then if you divide 2 to 2, remainder is 0, but remain is 1. Another 1 is left. So you put 1, the leftmost column, which means, and you have to make sure that, ladies and gentlemen, you have to understand that the last part, we have to think that way. Okay, in that way we can use that very easily. And let's continue with other slides. And this is the other way we can make it right. How we gonna convert decimal to binary? Ladies and gentlemen, imagine starting from the left part. If you have number 2, if you divide 2, the remainder is 0. Why? Because if you divide that one, it's minus 0. And how are you going to do it? Starting from the 0 and 1. And writing from that, either you're going to write from left to right 1 to 0, or right to left. Remainder 0 and then left 1. Second, 15 numbers. And remember that if you divide this one to 7, remainder is 1. Starting from right, sorry, in that way. That's the way. Okay, this one is first remainder. This one goes straight to that part. Okay, and this number, second one, 7 divided 2, and remainder is 1. This one is goes that part, and this one goes that part, and the leftmost, if everything finished, this one comes to the, okay, that's the way you got to use. Again, 32 is the same. Divided that 21. Number 1 comes in the rightmost. Then 21 divided 2, it means 1 remainder. And then 10 divided by 2, left 5, but remainder is 0. Then the other 5 divided 2, remainder is 1. This one goes exactly that part. Then 2 divided by 2, remainder is 0. That's the way. And 2 divided by 2, of course, the left is nothing, 1. This leftmost always 1. Don't forget about that. Well, what is hexadecimal numbers? This is a very extraordinary things, you should know that. But it's almost same way you can think about the binary and digital numbers. Since binary numbers, you have 2 digits, it's 0 and 1. If decimal number, you have 10 digits starting from 0 to 9. Let's talk about the 16 digits number. We can call hexadecimal numbers starting from 0 to 9. And also 11 is A, 12 is B, 13 is C, 14 is D, and 15 is E, 16 is F. These are called 16 numbers. As you can see, bottom of the examples, A is 1 digit, B5 is 2 digits, 6, C3 is a 3 digit, the last is the 4 digit numbers. We can talk about that. And then we can say that A is a hexadecimal number called in 10 in decimal representation. Also, we can continue with other parts, saying that we have called in the second part of the A, B, C, D, E, F, going on 16 decimal numbers on that part. Okay. Now, we can talk about later in that part. Let me see in the, this is the all 16 digit numbers from right starting 0, 1, 2, 3. Remember that A is 11, B is 12, let's see, 10, 12, blah, blah, going on. Ladies and gentlemen, as always, first digit is it's hexadecimal, base number is a 16, it's power 0, power 1, power 2, power 3. And if you understand this mentality of what's the base number is 16, which is hexadecimal number, and the power is always starting from first digit 0, second digit 1, third digit 2, fourth digit 3, fifth digit 4, sixth digit 5, and it goes on. Let's say converting hexadecimal to decimal. It's very simple, exactly the same as converting binary numbers to the decimal. Each digit is multiplied the value of its position and the numbers are called. Let's say A. A is 1 digit, it's number 10. Why? It is multiplied by 1. 16 over 0 is 1. Okay, it's 10. It is 10 hexadecimal number. B. Remember that. Let's starting from the beginning. B is 11. 5 is 5. This is 11. This is 5. What about if this is the first digit? It's 16 over 0 means 1. 1 times 15. 5, sorry. And it's 5. What about that one? This is 16 over 1 means 16. 16 times 11 then become adding 5, 185. Let's say B, C, 6, C, 3. 6, let's say, right, first of all, 6 is here, 6 is here. C is 12, 12. And 3 is 3. And starting from the right, this is What is first digit of the or hexadecimal numbers? 16 over 1 means 1. 1 times 3 is 3. It's coming from here. And second digits. What is 16 over power 1 means 16. 16 times 12 means 192. The third digit, it's 16 power 2. It means 256 times 6 comes 1516. Then we got the result of, in hexadecimal number system, 6C3 means in decimal number 1731. It's the same as last example. Okay, the last one is the converting hexadecimal numbers, decimal numbers to hexadecimal numbers. It's the same as converting decimal to the binary numbers. You just convert decimal decimals, you need to divide by 16. If you divide any number by 16, the remainder is always between 0 to 16. Then you can write it. If it's from 0 to 9, you can write down the numbers. Starting from 10, you say A, 12, 11, B, 12, C, and goes on. So that's the way you got to know about how to convert decimal to the hexadecimal numbers. That's all for this chapter.